What's up, guys? We're back at it again with trig functions. You're here with Miriam Garab, and today we'll be learning how to evaluate inverse trig functions. So before we even get started, there are restrictions you must place on sine, cosine, and tangent. In this picture, you can see that the answers for sine and tangent will come from the first and fourth quadrants. Your answer for cosine will come from the first and second quadrants. But you may be asking, wait, what answers? Well, at an xy coordinate point, sine is the y coordinate, cosine is the x coordinate, and tangent is y over x. The way I remember the difference between sine and cosine is by using this phrase. Why do you sin? 'Cause of my x. I hope this phrase is helpful. For our first example, we will be finding what the inverse of sine of 1/2 is. So on our unit circle, I'll be looking for the y-coordinate of 1/2, and this had to be in either the first or fourth quadrant, which it is. The angle measure located at the y-coordinate of 1/2 is pi over 6. Always keep in mind that the angle measure must be in radians and not degrees. For cosine and tangent, you would just do the same basic principle, except applying their own restrictions. The next example is sine of 7 pi over 3. In this example, you would have to get 7 pi over 3 in between 0 and 2 pi. To find it in the unit circle, you would need to add or subtract 2 pi. In this case, you would be subtracting 6 pi over 3 from 7 pi over 3. 6 pi over 3 is the equivalent of 2 pi. So after subtracting, you will get pi over 3. Looking at the unit circle, you will see that the y value of the coordinate point at pi over 3 is the square root of 3 over 2. Okay, moving on. In example number 3, we have the secant of the inverse of cosine of the square root of 3 over 2. You always do what's inside of the parentheses first. So first, you will need to find the inverse of cosine of the square root of 3 over 2. Looking at the x values in our unit circle, in the first and second quadrant, we see that the inverse of cosine of the square root of 3 over 2 is located at the angle measure of pi over 6. But we're not done. Now, we must find the secant of this angle measure. Secant is the reciprocal of cosine. So, if the cosine is the square root of 3 over 2, secant would be 2 divided by the square root of 3. But knowing you cannot keep a square root in the denominator, we must rationalize. After rationalizing, you get your final answer as 2 times the square root of 3 over 3. And finally, our challenge problem is tangent of the inverse of cosine of sine of 17 pi over 3. To solve, we must work from the innermost part of the expression and work our way out. The first step is to get 17 pi over 3 in between 0 and 2 pi. In order to do this, we must subtract by 2 pi. In this case, the equivalent of 2 pi is 6 pi over 3. After subtracting 6 pi over 3 twice, we finally get a value that's in between 0 and 2 pi. The value is 5 pi over 3. Now, we must find sine of 5 pi over 3. Looking at our unit circle in the fourth quadrant, we see that 5 pi over 3, the sine of that would be negative square root of 3 over 2. Looking back at our original equation, we must now find the inverse of cosine of negative square root of 3 over 2. To do this, we must look towards the second quadrant. We can see that the inverse of cosine of negative square root of 3 over 2 is 5 pi over 6. And finally, looking back towards the original equation, we must find the tangent of 5 pi over 6. To do this, if you remember, we must do the y-coordinate divided by the x-coordinate. In this case, you would do 1/2 divided by negative square root of 3 over 2. After doing this, you will see the answer to this lengthy problem is negative square root of 3 over 3. I hope you enjoyed this video, and thanks for watching.